Hi guys, welcome back. Today's topic is Huffman coding. Huffman coding, or you can say Huffman algorithm, is what? It is a data compression technique, or compression, you can say data compression algorithm, or it can also be known as variable length coding algorithm, in which the size of data is to be reduced or the message is to be reduced. See, sometimes when you store something in your computer and the size of that file is very big, then what you do is you compress that file and then you store that file in your computer so that it will take less time. Okay, so that's what the compression means, reducing the size of the message. Okay, secondly, when you want to transfer something on network, if you want to transfer a file from sender to receiver, then if that file or that message is compressed, then obviously it will take less cost, or you can say the bits which are used to represent for that message will be less. That is what the compression means. So in this video I am going to discuss with you fixed length coding and also the variable length coding technique. See, simple funda is what? When something is to be transferred on a network, then what is the funda that, suppose you want to transfer this message, then each character will be coded in ASCII form. Okay, and then suppose A is to be transferred first of all, then ASCII coding for A is what? That is ASCII code is 65, and then this ASCII code will be converted into its binary form. 65 को हम कैसे लिखेंगे? 0 1 1. Okay, this is the binary form for this A. To transfer this A, first A will be this ASCII coding will be used, and that ASCII code में क्या होता है? 8 bit will be used to represent a character. Okay, so this data is to be transferred. For a single character, how many bits is to be used? 8 bits. Fine, in case of a normal message. Okay, now see, in this message, suppose we want to transfer this message on a network, then how many bits is to be used? See, I was saying the cost when data is to be compressed, then for transferring that data or that message, the cost will be reduced. Cost means number of bits to be used. Okay, here cost means the number of bits to be used. Now you want to transfer this message without applying any compression technique, then the simple funda is by default what is the technique? Every character would be transferred into 8 bits binary form. Okay, how many characters are there? 20 characters are there. These are 20 characters. Okay, then how many bits will be required? 20 characters are there, and for each character how many bits will be used to represent that character, because computer only understand the language of 0 and 1. Okay, 20 into 8, that is 160 bits will be used to transfer this message normally without using any compression technique. 160 bits is to be used. Okay, now see, this is also known as what? Fixed length coding. Why this is known as fixed length coding? Because each character is simply a string of zeros and ones. Okay, and each character is having 8 bits. Fixed length we have. See, A is represented by this one. B is what? B is ASCII code is what? 66, and 66 would be converted into this binary form, and this would be 0 1, something like that. This is the binary code for 66. Same with C. C is what? 67. See, in this message I am taking only A, B, C, D and E. Only 5 characters I am taking, just for a simple example. A, B, C, D and E. 68, and this would be 69. Same, 67 would be converted into binary digit. Okay, binary form, and each character is represented with 8 bits. So this is what? Fixed, na? Each character is having 8 bit representation. That is why it is known as fixed length coding. Fine. And in fixed length coding, or to transfer a simple message without any using any compression technique, the cost is what? It will take 160 bits. Now after applying some compression technique, we can reduce the length of this message, or you can say the cost of this message to some digits. Maybe 160 से कम होके 120 आ जाए, 100 आ जाए, it depends. Okay, we will see that technique also. Now see, when we are using 8 bits, I am just telling you a simple funda before discussing this one. Suppose you have 2 bits, ठीक है, 1 and 2. Now with the help of these 2 bits, how many combinations are possible? 0 0, 0 1, 1 0 and 1 1. 4 different combinations are possible. Yes or no? Now with this 4 different combination, you can represent 4 different characters. Let us suppose with 0 0 I am representing A, B, C, and for 1 1 I am taking this D. Okay. Now if you have 3 bits, 1, 2 and 3, how many different combinations are possible with these 3 bits? 8 combinations. I hope you know this concept. Okay, 2 raised to power 3, that is 8, something like this, 0 0 0. Okay, so with the help of 3 bits, if you are taking 3 bits rather than 8 bits, then we can represent how many characters? 8 characters, 8 different characters. Fine. Similarly, if you are taking 4 bits, then how many different characters you can represent? 2 raised to power 4, that is 16. Here we are having 8 bits, then we can represent how many different characters? 2 raised to power 8, I think that is 256 characters. Fine. But we are taking one simple example. In this example, how many different characters we have? Only 5 characters we have, because A is repeating, B is also repeating, C is repeating, D is repeating and E is also repeating. Okay, different characters are only 5, A, B, C, D and E. So with the help of 2 bits, can you represent these 5 characters? No, we cannot represent, because with the help of 2 bits only 4 different characters can be represented. That is why we will take how many bits? 3 bits. With the help of 3 bits, how many different combinations are possible? 8 combinations. We have only 5 characters, so this one is ideal case for us. Okay, so rather than taking 8 bits, we will take what? 3 bits to represent each characters. Suppose for this one I am writing A, B, C, D and E. These are 5 characters we have. These are still unused, or you can say left. Okay, now suppose we are taking this technique. This is our on technique. Okay, now how many to transfer this message? How this message will be transferred? For A we will write what? 0 0 and 0. Next is B. For B what is written? 0 0 1. For B again 0 0 1 and something like this we can write the coding. Now how many total bits are required to transfer this message? Total bits we have what? 20 into, for each character how many bits are to be used? 3 bits for each character. 20 into 3, that is 60 bits. Fine. Here bits was 160 bits, sorry. Now in this case one more thing is what? The main funda is, the problem will be there when decoding that message. Suppose we have transferred, we have encoded this message and we have transferred. Now how the receiver will know that 0 0 0 means A? How that receiver will decode that message? Message receiver को क्या मिलेगा? 0 0 0 0 0 1 and this something like this. Now how the receiver will know that 0 0 0 means A, 0 0 1 means B? That is the problem ना in the case of decoding. So उस problem को solve करने के लिए वो क्या होगा? We will also send this table with this message. Fine. Now when the receiver gets this message as well as this table, then easily the receiver will see the message and then will verify with that table, and then he can easily say that 000 means what, A, 001 means what, B, because in this table we have already written 000 means A, 001 means B, C, D and E, something like this. So this table will also be sent. Now for sending this table, obviously some bits will be required. See, this 60 bits are just for this message. Now here we are sending this table also. In case of normal message आप जब ट्रांसफ़र कर रहे थे, no need of transferring the table because by default 8 bits required होंगी, और सबको पता है इसका वैल्यू ऑफ A is what, 65, मतलब इसका कोडिंग will be used. Simply 160 bit हो जाएगा, no need to send any table, but in this case we have to send this table. Okay, now for sending this table, how many bits is to be required? See, A, B, C, D and E, these are characters. Obviously these 5 characters is to be sent. Then characters कैसे send होंगे? Characters will be converted into that ASCII code, then into the binary form. And binary form में क्या होगा? Each character would take what? How many bits? 8 bits. Okay. Now we have what? 5 characters. Into, for each character how many bits would required? 8. ठीक है? 40 bits. Plus, see these bits are also to be transferred ना, because ये bit आपके किसके लिए हैं? Only for these 5 characters. Now corresponding to these 5 characters, we are also sending 000. Corresponding to this B, we will also send 001. So ये भी तो आपके bits होंगे ना? Fine. Now how many bits are there? These are how many bits? For 5 characters, how many bits will be required? 3 bits. 5 into A के लिए भी 3, B के लिए भी 3 चाहिए, C के लिए भी 3, D के लिए भी 3 और E के लिए भी 3. 5 into 3 plus 15, ये कितना हो गया आपका? 55 I guess. Total number of bits will be transferred 60 plus 55 means 115 bits. Okay, when you use this technique, this is also fixed length coding because we have used 3 bits for each characters. 3 bits are fixed na, but we haven't used 8 bits. Here we are using 3 bits. This is customized code, own code. Okay, in this case 115 bits is to be used. Now what is there in Huffman coding? We will discuss now Huffman coding. This is what? Variable length coding. Variable length coding. This is what we have discussed was fixed length coding. Now what is variable length coding? Huffman coding में क्या होगा? Maybe A would be represented with 3 bits and B would be represented with 2 bits. Maybe C would be represented with 2 bits. D would be represented with 3 bits, E maybe with 4 bits. So this is variable na, because in this case every character is represented with 3 bits, that is fixed, but in Huffman coding maybe A would be represented with 3, 2, then B with 2 bits and C with 2 bits, like something like that. So this is variable length coding, that is not fixed. Okay. Now how we will compress this message using Huffman coding rather than ASCII coding? We will not use ASCII coding, we will use what? Huffman coding. Now we have drawn a table, and in this table we have written the frequency, or you can say count of each characters. See how many different characters we have? 5 characters, A, B, C, D and E. And A is repeating 4 times, B is repeating 7 times, C 3 times, D 2 times and E 4 times in this message. So this is what? Frequency, or you can say count. Okay. Now the first step is you are supposed to design a Huffman tree, and how that tree is to be designed using Huffman algorithm. First of all, arrange all the characters according to their increasing order of their count. Okay. So, very first the least frequency or the count is what? 2. Then we will write D first, then C, then E, A and B. Fine. And the count of D is what? 2, for C it's 3, for E it's 4, for A it's 4, and for B it's 7. You can either write down A or E, it's up to you, because we have 4 and 4 both are same. Now first of all, take two characters which are having least frequency or least count. Which are two characters? D and C, because 2 out of 2, 3, 4, 5 and 7. Which are least? 2 or 3. Or while writing a program or something like that, you can say we arrange these characters in priority queue, and priority is what depends on the frequency count. If frequency count is 2, then it will have greater, more priority, then C, then E, then A and B. So this one you can say priority queue, or this can also be implemented using min heap tree. Okay, I am just going to tell you in the layman language. Okay, what is the funda? Take D and C like this. See, we are taking D and C. For D we have count is 2, for C it's 3. Now merge these two and create a parent node, and the count will be 2 plus 3, that is 5. Now we are done with this D and with this C. Okay. Now in our priority queue, what we have? We have 4, 4, 7 and this 5. See, one new, that the parent of 2 and 3, that is 5. Now arrange 5, 4, 4, 7 in increasing order of their frequency. Fine. So first of all, what you will write? E, A. After E and A, what is there? This one. This is complete node now. Then it would be 5 and then 7. Okay. Now out of 4, 4, 7 and 5, take the two characters having least frequency. We are having E and A, 4, 4. Okay. Now see, E, A, and these are having what? Count is 4 and 4, and after merging, what is the count? That is 8. Now we are done with this E and this A. Now we are left with 3 frequency count. One is this 7, one is 5 and one is 8. Now arrange this 7, 5 and 8 in increasing order of their frequency count. So first of all, what we will write? This node 5, then 7 and then 8. Now out of these 3, take two characters having minimum frequency. We will take this 5 and this 7. Minimum, see, आपको ये ध्यान रखना है, always the minimum count, frequency count would be left side. Okay, and the you know that greater than that minimum would be on right side. Then we will take 5, 7, 8. Out of these, what we will take? 5 and 7. ठीक है? And when you are designing a tree, this 5 would be left side and this 7 would be right side. Okay. Now we don't have so much space, तो मैं इसी में इसको update कर रही हूँ. We have this node 5 and we are merging this 7 with this 5 ना. Then we will write this 7 at this level only, this level only. You will not write 7 here. Okay. You will write 7 here and 7 के लिए what we have? B, and merge these twos. And the total would be what? 12. Now we are done this with this B. Now only left frequencies are this node. One is this node having frequency 8 frequency count and one is 12. Now these two, arrange these two in increasing order of their frequency. The first node would be this one, 8 पहले आएगा और 12 क्या आएगा उसके बाद आएगा. और just we are left with only 2 nodes, so हमें दो तो नोड लेने ही है, दो करेक्टर हमने लेने ही है, तो we will take 8 and 12. But we will not write like this. 12 आपका यहाँ पे है, उसको 8 को मर्ज किया और आपका यहाँ 20 हो गया. No, this one is wrong. Always the rule is what? The minimum frequency will be on the left side and the greater than that would be on the right side. Then tree would be, we will take 8 and 12. Now tree would be something like this. Here we have E, A, 4, 4 and this one was 8 and 8 this side what we have this 12. We are merging these two और 12 हम कैसे हमारा बना है, यहाँ पे था 5, यहाँ पे था अपना 7, 5 के नीचे क्या है 2 और इसके क्या है नीचे that is 3. और you can say here what we have D, here what we have C और 7 के यहाँ पे क्या है अपने पास B. and after merging of these two, this one what we have 20. Okay, so this is our final tree, this one. The characters will always be in the at the leaf node E, A, D, C and B. Now we have drawn this tree. Now second step is what? You have to traverse this tree and you have to assign 0 and 1. Now 0 would be assigned to the left side and 1 would be assigned to the right child. So 20 का left child है, this one 0 would be assigned. Here to the left side 0 would be assigned. Right side 1, right side 1. Now see this one, this is right of 8, then 1 would be assigned. Now 12, here it's what? This is left, then 0, left, 0, right side hai, then 1. Now we have assigned 0 and 1 to each this edge. Okay. Now you have to find out the coding, Huffman coding for each characters. Now how to find out the Huffman coding? Okay, now this is our Huffman tree. Okay, find out the coding for each character. For A, have to find out, see, character would be at the leaf node A. Have to traverse the tree. Always we cannot traverse the tree from the leaf node. We will traverse it from the root 1. Traverse it from the root and traverse the tree till you reach the node A. Now 0 and 1. Here is what? A. The coding for A would be what? 0, 1, 0, 1. For B, it's what? 1, 1, 1, 1. For C, what is this coding, Huffman coding? Here we have 1, 0 and 1. 1, 0 and 1. For D, 1, 0, 0. 1, 0, 0. For E, 0, 0. Okay. Now this is the Huffman coding. See, every character is not having the fixed code, having variable code. A is represented with 2 bits, C and D are represented with 3 bits. So that is why it is known as what? Variable length coding. And one more point you have to take care of it. See, आपको इसमें देखने से क्या पता चल रहा है? The frequency of, or you can say the count of B is what? Highest. So the letter or the character having the highest or the maximum count, the character which is generating more, many times, which that character will have the Huffman code having less number of bits. Huffman code of this B is what? Having 2 bits. And for 2, see, D is occurring 2 times and Huffman code for this 2 is what? Having 3 bits. Maybe some character is there which is occurring 1 times and the Huffman code of that character would be of 4 bits. So जो character सबसे ज़्यादा टाइम आएगा, जिसकी frequency सबसे ज़्यादा होगी, उसका Huffman code में bits क्या होंगी? कम होंगी. Okay, that is the rule. And this Huffman coding will also satisfy the prefix rule. I will discuss that rule in later. First of all, let us find out the size of, or you can say the total number of bits in transferring. While you are transferring this message, how many total number of bits would be transferred for this message. Okay, now you cannot say कि 20 characters are there, 20 into, पहले हमने क्या किया था, 20 into 8 when we were taking 8 bits for representing a character. दूसरे टाइम हमने क्या था, 20 into 3, at that time we were taking 3 bits for representing the character. But यहाँ पे आप ऐसा कुछ नहीं कर सकते because we are not having the fixed bits, we are having variable number of bits. Now how to calculate the total number of bits, or you can say the length of this message, how you will calculate? See, frequency of A is what? 4. 4 into number of bits to be used to represent this A is what? 1 and 2. 4 into 2 plus for B 7 into 2 plus for C 3 into 3 plus for D 2 into 3 plus for E 4 into number of frequency into the number of bits 1, 2. The total would be, total number of bits would be 45 bits for only this message. Now how the message will be decoded? At that place of A, what you can write? 0 1. At the place of B, what you will write? 1 1. At the place of B, what you will write? 1 1. At the place of C, what you will write? 1 0 1, and like this. This message or the message in binary form will be sent from sender to receiver. When the receiver get this message, then how the receiver will decode this message? How the receiver will get to know that 0 1 means A, 1 1 means B? How? तो उसके लिए क्या करना पड़ेगा? Either you will send this table or you will send this tree. Okay, tree in serialized form, because obviously you can't send this tree something like this. इस serialized form में आपको tree को भेजना पड़ेगा. Okay, now either this table would be sent or this tree would be sent, so that by traversing or by looking at this tree or this table, this receiver will get to know that the code 0 1 is for what? A. The code 1 1 is for what? B, something like this. So 45 bits आपका आ गया for only this, the length of this message. This is the length of this message only. Okay, plus we will send this table, suppose. Okay, now how many bits would be required to send this table? In this table we will send the characters and corresponding code, Huffman code for these characters. Now for sending these characters, how these characters will be sent? See, characters will be sent what? The characters would be converted into ASCII code, then ASCII code से character कैसे convert होंगे into 8-bit binary form. Okay, now we have how many characters? 5 characters. Into each character would be represented with 8 bits in ASCII code. Then 5 into 8, that is 40. Now along with these characters, these Huffman code will also be sent. For characters, 40 bits would be required. For sending these codes, how many bits would be required? 40 plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How many bits are there? 12 bits would be required. The total would be what? 52. Now total bits to be transferred from sender to receiver would be 45 plus 50. 2, that is 97 bits. So in Huffman coding, when you compress this message, any message using Huffman coding, or I am taking example of this message, then 97 bits would be required. 97 bits would be used from sent from sender to receiver. पहले 160 थी, उसके बाद compress करके कितना हुआ? 115, and using Huffman coding it becomes what? 97 bits. Okay, now see how the receiver will decode this message. Suppose receiver is having this tree in the serialized form. Okay, now how that decoder will decode this message? When the when receiver will see the message 0, then traverse करो tree को. 0 से आप कहाँ पे आएंगे? to 8. Did you get any character? No. So 0 से हम कोई भी character यहाँ पे नहीं लिख सकते. Check out the next bit, that is 1. 0 1. Traverse this tree. 0 1. Of course we have reached to a character A. Then the receiver will decode this 0 1 and will write what? A. Now again this one is done. Character मिल गया. उसके बाद next bit is what? 1. Traverse this tree. 1. We have reached to this 12, but is there any character here? Have you reached to the leaf node? Because characters are at the leaf node only. No, we are still in the middle of the tree, so we cannot write any character here. Now next 1 1 1. Oh, you find a character, that is B. Then receiver will decode it like B. Again 1, you will see 1, again 1 1, then again B. Fine. Like this, the receiver will check out this tree and then decode this message. For C, how this would be done? Next bit is what? 1 1, because here is no character. The next bit is 0 1 0. Here also we have no character. The next bit is 1 1 0 1. Yes, we have reached to a character C. Like this, the message will be decoded with the help of this Huffman tree. So along with the data, along with the message, either the tree or the table would be also be sent. Okay, Obviously tree would be sent in serialized form only. Okay, so these are the number of bits would be required when you compress this message or you send this message using Huffman coding. Now the time complexity of this would be theta n log n. Now see, I have told you one funda, that is prefix code, that Huffman coding works on the technique that is prefix code. What is the prefix code algorithm, or what is the prefix code rule, you can say? It says no code is prefix of another code. Let us take a simple example, then you will get it. File, or in example we have only 3 characters, and the code for these characters are, for A it's 0, for B it's 1, for C it's 0, 1. I am taking the simple example 0, 1 and code for C is 0, 1. Now suppose from sender to receiver one message has been transmitted with in the encoded form, and that message is what? 0, 0, 1. Now the receiver will decode this message with the help of this table, because this table will also be sent with this table, with this message. Okay. Now there would be ambiguity in decoding this message. How the receiver will decode this message? First bit is what? 0. Receiver will check in this table. 0 is for what? A. Now this 0, first 0 is for what? A. Now next bit, receiver will check the next bit. 0. Again this 0 is for what? A. Now 1. 1 is for what? B. And the second option would be what? For 0 it's A, and again for 0, 1, for 0, 1 the receiver will decode it C. Now this one message will be decoded, may be decoded in 2 forms, AAB or AC. So this is ambiguity, because we have sent only one message and receiver को नहीं पता चलेगा कि which one is right, this one is right or this one is right. And why this ambiguity is there? Because this 0 code of this A is prefix of this code 0. Okay. For C code is what? 0, 1, and अकेला 0 किसके लिए है? A के लिए. So इस 0 को हम बोल सकते हैं, this one is what? Prefix. And this code of this A is what? Prefix of another code. So this should not be happened. No code should be prefix of another code. Okay. Only if this condition is satisfied, then only there would be no ambiguity at the receiver side while decoding the message. And the Huffman coding will always ensure the prefix rule, the prefix code or prefix rule. You can easily check कोई भी कोड किसी भी अनदर कोड का यहाँ पे प्रीफिक्स नहीं होगा. ओके, सो हफमैन कोडिंग के लिए आपको ये बात भी ध्यान रखनी है. Huffman coding will always follow this prefix rule. And what is the prefix rule? मैंने आपको इस example के through बता दिया है. Now in a summarized way, if I tell you the Huffman coding, then these are the 4 points. It was discovered or developed by David Huffman in 1951. Next is the encoding follows the prefix rule. I have already discussed what is the prefix rule. No code can be a prefix of another code. Next is the most generated character will get the small code and the least generated character will get the larger code. We have already discussed in that example. Okay. Now the time complexity of this Huffman coding is theta n log n. In next video, I'll discuss you one example of Huffman coding with probabilities. Sometimes in exam they can give you the characters and they will give you not the frequency or count, they will give you the probabilities of those characters, and then they will ask you what is the average length of the message. So in next video I will discuss with that question. Okay, till then take care, bye bye.